Hi everyone, let's jump into our maths lesson then. So in Fluency Day, what we're going to look at today is what happens when we divide by 1. So just like yesterday, we're going to work systematically. That means we're going to work in a logical order that makes sense, and then we're going to look for patterns from there. So let's start with the number 1. That means I've got one counter and I am dividing it by 1. That could either mean grouping it into groups of 1, or it could mean sharing it out between one group. But I think I'm just going to use sharing. So this is my one group here to represent the one group that I am sharing it into. So my one counter shared into my one group gives me how many counters in each group? That's right, 1. So let's make a note of that down the side. There we go, that's noted down here for us to keep a track of. So now, working systematically, let's try the next number. Let's try 2. So that means now I've got 2 counters to start with, and I'm sharing them into one group. There we go. How many counters are in my one group? That's right, 2. So over here, we can note that 2 divided by 1 equals 2. So working systematically again, let's try the next number. The next number would be 3. So that means we need to get 3 counters to start with. There we go, 1, 2, 3. And I am sharing those 3 counters into my one group. How many counters are inside the group? 3. Excellent, well done. So let's make a note of that here. That 3 divided by 1 equals 3. Maybe you're starting to notice a pattern already. Let's try the next number in our systematic sequence. So this time we're going to do 4. So that means I'm starting with 4 counters and I am dividing it into one group. So 4 shared into one group. There we go. How many counters are inside the group? 4, fantastic. So then we can say that 4 divided by 1 equals 4. Have you started to notice a pattern at all about what happens when we divide a number by 1? Excellent. You may have noticed that when we divide a number by 1, our answer is the number that we started with. And that's because, as we can see, if we look at this from a sharing context, then what happens is all of those counters have to stick together because they've got to fit into one group. So nothing's changing. They're not being shared out. They are keeping together and being shared into that one group. So that's why it's the same. Or if we looked at it in terms of grouping, for example. So let's have a look at 4. And we're saying 4 being grouped into ones. Well, I would make 1 group of 1, 2 groups of 1, 3 groups of 1, 4 groups of 1. So even if we looked at it in terms of a grouping, then we would see here that I can only make a group of 1 for each of the counters that are in my whole. So from this, we've learned that when we divide a number by 1, our answer is the same as the whole that we start with. So with that in mind, I would like you to have a go at pausing the video and answering these questions. And when you're ready, we'll play the video and go through it together. Super, hopefully you've had enough time to have a go at that. Let's go through the answers. So all these numbers are being divided by 1. So that means that our answer is going to be the same as the whole number that we're starting with. So 6 divided by 1 would be 6. 7 divided by 1 would be 7. 8 divided by 1 would be 8. 9 divided by 1 would be 9. 10 divided by 1 would be 10. 12 divided by 1 would be 12. 15 divided by 1 would be 15. 20 divided by 1 would be 20. 24 divided by 1 would be 24. 39 divided by 1 would be super. If I did 1,000,000 divided by 1, it would be 1,000,000. Fantastic, well done. So what we're going to have a look at today is the relationship between multiplication and division. So when we first started out this unit, coming back after the Christmas holidays, we were looking at representations just like the one that we've got in front of us, objects that had been put together in equal groups, because that's what multiplication is all about. It's all about equal groups of something. So let's have a look at this from a multiplication perspective, first of all. We learned that multiplication was commutative. Well done if you said that word. So multiplication is commutative. So we first started to learn that we could say that we've got so many groups of something. So how many groups do I have? 1, 2, 3, 4, 5, 6, 7, 8. So we were saying that we've got 8 groups of, how many objects do I have in each group? That's right, I've got 8 groups of 2. And then what we needed to do is we need to count in our 2's 8 times to work out our product. We would say 2, 4, 6, 8, 10, 12, 14, 16, and that is our product. But going back to what we learned about multiplication being commutative, that means that we would still get the same answer even if these were switched in the opposite order. But we also started to have a look at a different way that we could communicate equal groups or multiplication. So instead of saying that we have 8 groups of 2, what we could actually begin to say is that we've got 2 cookies 8 times. Remember? So we said we've got 2 cookies 8 times. And I don't need to work out the answer again by counting in my 2's 8 times, because I know that multiplication is commutative. So that actually means that the product is just going to be the same. So this one pictorial representation is showing us both 8 times 2 equals 16 and 2 times 8 equals 16, because we've got 8 groups of 2 and all together we have 16, or we have 2 8 times and we still have 16 altogether. And then after we learned about multiplication, we then started to look at division. Now division is what we call the inverse of multiplication. That means it's the opposite. Well done. So just like addition and subtraction are opposites of each other, multiplication and division are also opposites. So you might notice here that our biggest number, our whole amount, comes at the end of a multiplication. But if you think back to the last few lessons that we've been doing on division, that the whole amount that we have actually comes at the beginning. So we've been looking at 16 biscuits to start with, or 16 cookies. And we might say that those cookies have been grouped into, so remember there are two ways of looking at division. That's why we've got two division equations that we can write. So we can say that they have been grouped, because grouping is one way we can look at division. So they have been grouped into, what have they been grouped into? Well, they're in groups of 2. So I could say that 16 divided or grouped into 2s equals how many groups? Well, I get 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2, 5 groups of 2, 6 groups of 2, 7 groups of 2, 8 groups of 2. But remember, we can look at division in also the context of sharing. So I could say that I've got 16 cookies, and instead of saying that they've been grouped, I could say that they've been shared. They've been shared between how many groups? Well, they've been shared between 1, 2, 3, 4, 5, 6, 7, 8 groups. They've been shared between 8 groups, and then that gives us how many cookies inside each group. That's right, that gives us 2 cookies inside each group. So this one pictorial representation here has showed us two different multiplication equations and 2 different division equations all at the same time. And that is because the relationship that multiplication and division have, they are the opposite of each other. So is there anything that you notice in particular about these equations? Just pause the video and have a think. Maybe tell somebody who's in the room with you, or maybe write your ideas down or say them out loud. Super, so you might have noticed, for example, that in all of those equations, the digits, the 8 and the 2 and the number 16, they're all there, just in different orders. So they all use 8, 2 and 16 in different orders. You might have noticed that with multiplication, the biggest number, our whole amount, always comes at the end. Remember, we did do it as well where we could shift our equals to the front, but our 2 smaller numbers, our products, go around the multiplication symbol, and then our product is the biggest number, what that is equal to. But with a division, we must always start with that, because what we're doing is we are breaking them down either into smaller groups, basically, either into groups of, or sharing them out between a certain number of groups. So that's why. And you can see here the relationship between multiplication and division by the fact that they all use the same numbers in a different order. So that's what we're going to do today. We're going to have a look at some representations, and we're going to have a look at how they show us both multiplication and division as well. So now we've got can you remember what this is called? It's an array. Well done. So an array is a way of representing multiplication and also division. And it's showing you the 2 different ways that we can make our groups of. Remember, we could make our groups going horizontally along the rows, or we could make our groups of going vertically down the columns as well. So let's start off with our multiplication. And I'm going to group them going down this way. There we go. I'm going to say I've got 1 group of 4. Two groups of 4, 3 groups of 4, 4 groups of 4, 5 groups of 4. There we go. So we've got 5 groups of 4, or we could say that we've got 4 5 times, or even by showing the grouping this way, it would be the equivalent of having 4 groups of 5. Equivalent means that it is equal to. There you go. So we've got 4 groups of 5 and it's equivalent to 5 groups of 4. Or maybe we've got 5 4 times. So lots of different ways that we can read these multiplication expressions. But either way, we need to now work out our product. So let's have a think. Well, if I do 5 groups of 4, that would mean that I've got 5 groups, and in each group I would have 4, but I can't quite count in my 4s yet. So remember, when 5 is a factor, I can use my 5 times tables. So that means I need to count in my 5s 4 times. So I would say 5, 10, 15, 20. Do I need to work it out again here and count again? No, because my product is the same here. Lovely. So now I've got my 2 commutative multiplication equations. All that's left is for me to do my division. Now, when we do division, we must start with our whole. Fantastic. So the whole is now going to start here. So I've got 20. Now, both of my divisions must start with my whole, so I can just fill that in straight away. Now, I could look at division in terms of sharing or grouping. So let's start with grouping. There we go. So I could say that now I'm not going to say I'm going to group them into 10, for example, because 10 is not one of my factors. And if we go back to this, we know that our division equations will be using the factors of our multiplication. So this cannot be 10, for example, because we don't have groups of 10 being represented here. So we could say that I have got 20 grouped into 5s. So 20 grouped into 5s gives us how many groups? 1, 2, 3, 4 groups. Now, even though division can show us both sharing and grouping, what's really interesting about arrays is that they show us both ways of grouping at the same time. So here we've grouped them into 5s, but we could also group them into 4s. There we go. So we've got 20 counters divided into groups of 4. And that would give us how many groups of 4? That's right. 20 divided into groups of 4 gives us 5 groups. And you'll notice again that for our multiplication, our whole is here at the end. Remember, we could write it and we could actually say that 20 is the same as 5 times 4, or 20 is equal to 4 times 5. But what I mean is that the whole is by itself on one side of that equal sign. Whereas for our division, it is part of that expression. It is right next to that division symbol. You must start with your whole in a division. And then you can group it either into groups of 4 or groups of 5, or maybe you could share it into 5 groups or share it into 4 groups. But you will notice that for each one of our multiplication equations, the commutativity means that our 2 factors can go in any order. Now, division is not commutative, because for division to be commutative, it's these 2 numbers here. I'll just highlight those. It's these 2 numbers here that would need to be switched around. And do you think it would be possible if I had 5 things for me to split these up into 20 groups? No, because I don't have enough here to make 20 groups. So it's not commutative. But what you might notice is that the number of groups and the number of objects inside each group can move around that equal sign. Okay, let's look at some bar models then. Let's have a think about our multiplication. Well, I can see from my bar model that I've got groups of 10. And my bar model is showing me 3 boxes on the bottom. So that's showing me that I've got 1 group of 10, 2 groups of 10, 3 groups of 10. So I've got 3 groups of 10. Or you could say that I've got 10 3 times. I've got 10 3 times. And my whole, I don't even need to calculate it because it's already on my bar model for me, is 30. But just to double check that, I could either count in my 3s 10 times, but I'm much better at counting in my 10s. So I'm going to count in my 10s 3 times, 10, 20, 30. So let's have a look at our division. Our division must start with the whole. Excellent. So we're going to put our whole here for both of our division equations. Now we can look at it either in the context of sharing. So we could say that the 30 has been shared out into 3 groups. And inside each group, I've got 10. Or I could look at it in a context of grouping and say, well, 30 has been grouped into groups of 10. And that gave me 3 groups. Super. Okay, so let's have a look at these equations then. On one side, we've got some multiplication, and on the other side, we've got some division. Why don't you pause the video and have a go at seeing if you can match each of the inverses to each other. When you're ready, we'll go through the answers. Super, so hopefully you've had enough time to go through that now after pausing the video. Let's start over here then. So 4 times 5 equals 20. So I am looking for a division that will have 20 as its whole, and the whole goes at the beginning. So it's not this one, it's not this one, it's not this one. This one has 20 as its whole. So we've got 20 divided by 5 equals 4. So then I would match these 2 together. This one then, 3 times 2 equals 6. So 3 groups of 2 equals 6. I'm looking for a division that has 6 as my whole, and the whole goes at the beginning. So it's not those. I can see this one, it's got a 6 divided into groups of 2 or 2 groups equals 3. You will see that it has that relationship. So it's this one. 7 times 10 equals 70. So 7 10 times, or 7 groups of 10 equals 70 as its whole. We are looking for a division that has 70 as its whole. And we can see this one has 70 as its whole. And we're dividing it by 7. And we would get 10. So 5 times 6 equals 30. Well, 30 is its whole. I'm looking for a division with 30 as its whole. And you can see it's got 5 groups of 6, 5 groups of 6. So that then means that 24 divided by 2 equals 12 is the inverse, the opposite of doing 12 times 2 equals 24. The next thing I'm going to show you how to do is to have a play with some digit cards. So getting some digit cards, how many multiplication and division equations can you make from them? Well, I could say that when I do a multiplication, I'm going to say that it is equal to the biggest number. So I've decided I'm going to do multiplication. I've only got 2 digits left, so that would mean that 5 groups of 7 equals 35. So I'm going to write that over here. 5 times 7 equals 35. What's daisy? Well, I know that multiplication is commutative, so I could have said that 7 times 5 is the same as 35. I also know that I could move this to the front and say that 35 is equal to 7 times 5. But I could also rearrange my factors in this equation as well to say that 35 is also the same as 5 times 7. Now, I'm pretty sure that at this point we've exhausted all of the options for our multiplication. So let's switch out our multiplication for our division. Now, this is not correct. I can't just swap it over and write the same thing because the whole structure of division is different to multiplication. For a division, I must start with my whole number and divide that number into groups. So I'm going to divide it into 5 groups. So then that would equal, I've only got one number left, 7. So then 35 divided by 5 equals 7. But I did have the option to divide it, instead of dividing it into 5 groups, I could have divided it into 7 groups, and then that would give me 5. And that means 35 divided by 7 equals 5. And actually, just like with multiplication, I can move my equation, the answer of my equation, to the front and say that my answer is equal to 35 divided by 7. So 5 is equal to 35 divided by 7. Or remember, I had this one here where my answer was 7. I could say that 7 is equal to, there we go, 7 is equal to 35 divided by 5. So just from those few digit cards, I've been able to create all of these equations. And before I introduce your task for today, we're going to have a look at a reasoning question. So just pause the video and have a think. Is this array showing us which of these equations? Have a think. Which ones are true? Which ones are false? And when you're ready, play the video and we'll go through it. Super. So hopefully you've had a go at that now. Let's go through then. So 4 times 3 equals 12. Well, that could mean I've got 4 3 times, or I've got 4 groups of 3. Well, we could see here I've got 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3. That is absolutely true. But we also know that multiplication is commutative. So our array is also showing us 3 groups of 4. Well, that's 1 group of 4, 2 groups of 4, 3 groups of 4. So that is also true. Is it showing me that 12 groups of 3? Well, no, because we know that it's showing me 4 groups of 3. And in this equation here, 12 is our biggest number. And when we have a multiplication, our biggest number cannot be next to our multiplication symbol. So I know that this one is false. Is 12 equal to 3 groups of 4? Well, this is our biggest number. Yes, it's at the front, but it's not next to my multiplication symbol. All I've done is move this bit to the front of an equation that we've already said is true. Does that make it false if I move my 12 to the beginning and then say that it's equal to the expression from there? No, that's still true. Okay, let's do this one then. 4 divided by 12 equals 3. So this is a division equation. 12 is my biggest number. Now I know that when I have a division, my biggest number must come at the start. So this is all wrong. If I had 4 objects, I wouldn't be able to share them into 12 groups. And remember, the whole here is 12. That should be what's being shared. So that's false. And for that same reason, we can also rule this one out here because our whole is in the completely wrong place. So let's have a look at this one then. 12 divided into groups of 3. So if I divide it into groups of 3 like these here, do I get 4 groups? Yes, I do. And if I did 12 and I divided it into groups of 4, would I get 3 groups? Yes. So these ones with the tick are all true, but these 3 are false. Okay, it's your turn to have a go then now. You can either pause the video here or access these worksheets from the Byron Wood School website in the home learning section. The circle sheet is just an example of what we did earlier in the presentation. You've just got to match the inverses to each other. The semicircle sheet has some pictorial representations and some arrays. And just like we did earlier in our presentation, you've got to write for me 2 multiplication and 2 division equations for each one. The triangle sheet is bar models. So looking at the bar models, can you complete our multiplication and division equations? And then the square sheet is just like what we did with the digit cards earlier with 5 times 7 equals 35. Can you rearrange these digit cards in an order that creates as many multiplication and as many division equations as possible? Whew, that was a tough one. Once again, well done everybody. You're all doing amazingly well. We love seeing the work that you're sending in. And remember, if there's anything that you need help with, email through to your class email accounts and we'll do the best that we can. See you again for another maths lesson. Bye.